Okay, so how do we change a reaction rate? Well, temperature, increasing the temperature increases reaction rate. So that is a direct relationship. And this would be one that you are familiar with, because if you look at food spoiling, higher temperature, that's a faster reaction. Lower temperature is a slower reaction. Concentration, increasing concentration increases reaction rate. So again, we have a direct relationship. Both of these are increasing collisions. With temperature, moving faster, more collisions, or at least more with enough energy. Whereas concentration, literally you just have more particles, so you're going to have more collisions. Now, particle size, this is an inverse relationship because faster rate with smaller particles, because the reaction only happens on the surface. So if you imagine this, the reaction's only happening on the surface, but if we cut it, and we're pretending that I have the same surface area, you now see you have all these more surfaces that you've now opened up that the reaction can occur on. And catalysts, we mentioned when we were looking at our energy diagram, speed up the reaction because they provide a pathway that has a lower activation energy. Now, we already mentioned that reaction rate is a change in concentration per time. So this diagram has concentration on the y-axis, time on the x-axis. Right there, that's our green line. And you can see that it is decreasing because it's a reactant. So its concentration is decreasing. Right there, our blue line, that's increasing because it's a product. Now notice those rates are equal. That is because they have the same coefficient. Now if you look at the O2, it's increasing because it's a product, but its rate is 1/2 the rate of the NO2 or NO, because its coefficient is 1/2 the other coefficient. Now, if you look on the graph, you can tell that the rate is not constant, but it's changing. The rate is highest at the start of the reaction. In other words, the slope of a tangent line would be greatest. And the slope of the tangent line at any point is the instantaneous rate.